and in this video, we're trying to prove the energy theorem. So first of all, what is the energy theorem? The energy theorem states that the work done on an object is equal to the change in kinetic energy of that object. So let's define work done. Work done is the energy possessed by an object as a result of applied force and an applied force in a particular direction. So it's given by the force applied on the object times the displacement in the same direction of the applied force. So if the displacement is perpendicular to the applied force, then the work done is zero. And yes, then the next thing we need to understand is the kinetic energy. Now, kinetic energy is the energy possessed by an object because of its motion. So kinetic energy for an object to have kinetic energy has to be in motion, and it's given by half mv squared. So let's try to implement this kinetic energy in a way that we can use it to understand the energy theorem. So first of all, the kinetic energy possessed by this body at the initial position is given by half mv zero squared, where v zero squared stands for the velocity of the object, the initial velocity of the object. And the final kinetic energy will be half mvf squared, where vf squared is the final velocity of the object. So that means that the change in kinetic energy will be half m times the change in the velocity. So vf squared minus v0 squared. That way we have created an equation for the change in kinetic energy. So the next thing we'll do is to create an equation for the work done. So we already understood that the work done is the force times the distance or displacement in the direction of the force. And we already know that force is equals to mass times acceleration. So if you make acceleration subject to the formula here, acceleration is equal to force over mass. Now let's use the equation, the kinematic equations. One of our kinematic equations states that vf squared is equal to v0 squared plus 2ad, where d is the distance and a is the acceleration. So if we just substitute the value for a into this equation, we have this where f by m replaces it. So now we just want to make fd stand alone. That's the point of this whole calculation. So that way we can create a new equation for work done. So if you solve this equation and make force times distance the subject of the formula, we have that force times distance is equal to half m vf squared times v minus v0 squared. And if you recall, that is the same equation we got for the change in kinetic energy. So that way we have been able to prove that the work done on an object, which is the force times distance, is equal to the change in kinetic energy of that object. And that is what the energy theorem is all about.